Yay! Thank you so much, and thanks to Dawn for making us automated. So tonight I want to start by going back in time, and I want you to imagine that you're a scientist, and it's 1792, and you're going off to college in London. And you might aspire to be like this gentleman, a pioneer in multiple fields like physics, and you might also want to be a pioneer in medicine and also in music, and you might even want to decode the Rosetta Stone while you're at it. And if the year is 1792, you're able to do all of these different amazing feats, and you can do them while working all by yourself. Now, I'm sad to say that for all of us in this room tonight, in 2015, it is no longer possible for us to know everything. So there's been this exponential increase in knowledge and expertise across all fields and humanities, and frankly, our human working memory capacity has not kept pace with these advancements. And so fortunately, though, humans are a very creative breed, and we have evolved a way for us to know everything. Only we can't do it by ourselves, so the way that we've evolved to know everything is to work in teams with other people. And so this trend has been well documented in science, in the journal Science, by looking at the greatest publications, the papers, the patents, the ideas that get cited by the most people, that get picked up, that get linked to other people's works, and they're really generative of future thinking. And they did an analysis of, well, what percentage of those fantastic works are produced by teams, and what percentage are produced by individuals. And one thing that you'll notice is that if you go back to 1955, it's about 50-50. So we could say that, oh, there were still these kind of lone geniuses who would work by themselves and produce things that turned out to have wonderful impact. But by the year 2000, the tide had turned. And if you look across fields and disciplines, you'll see that there is an increasing reliance on teams to produce really high impact work. And this is, of course, controlling for a lot of things like, well, big teams have lots of people to cite that work and send it to. And there's a second trend brewing in here, which is that as knowledge gets more and more specialized, we find ourselves knowing more and more about less and less. And so not only do we have to work in teams to know everything, but we have to work in teams that are getting bigger and bigger and bigger. And so we have to work in extraordinarily large teams. So I want to think for a minute about some great inventions. And when you think about things like the light bulb or electricity, or perhaps you think about your iPhone, you probably think about people. And so we're all kind of hardwired to think about great inventions and have this image of Edison in his lab, or think about Ben Franklin or Steve Jobs. But the reality is that if we only look at these people and we focus on the solo inventor, we don't realize that great ideas, now and historically, have always been the results of human collaboration. And so Walter Isaacson, in his latest biography, concedes this point. So having written about Einstein and Steve Jobs, he said, you know, when I was writing about Steve Jobs and I was doing this background work and I was understanding the people who invented the personal computer and the people who invented the internet, it was clear to me that going all the way back to Ada Lovelace through to Alan Turing, that these people did not work alone, and that their contributions and the contributions that have ushered in the digital era have been the result of these collaborations and ideation that happens when people come in contact with each other. So teams are extraordinarily important in human endeavor. So tonight we're going to talk about 3 secrets of dream teams. And so we're going to look at teams and say, what are some of the secrets that they hold that explain which teams go on to be extraordinarily successful and which teams sort of fail to launch. But before I share the 3 secrets with you, we're going to go back and revisit some events in US history. Before Georgia Tech discovered water on Mars, there was a less exciting event that we have absolutely no responsibility for, which was, except perhaps that we weren't studying dream teams here yet, which was the Mars Climate Orbiter. So the orbiter was launched in 1998, and it was supposed to usher in fantastic accomplishments in measuring the surface and atmosphere of Mars. And the orbiter was the result of a lot of smart people working together for 10 years. $125 million went into just creating the satellite. And within a year of its launch, it crashed into the surface of Mars. And you may not remember the orbiter, but you probably remember the story that was released of why the orbiter crashed. And so it turns out that there were different pieces of software that were developed by different teams. And one team, of course, wrote the software expecting pounds, and another team wrote the software expecting newtons. And what we have is a major metric math mistake. But what's important to realize in this lesson is that it's not really about math at all. And so while it's a funny story to talk about a metric math conversion, what really happened here is that it's a failure of teams to be able to relay complex information. And so if we fix the math problem, there'll be another piece of complex information that they weren't able to transfer. So if we look at the official NASA report analyzing the orbital, you'll see they attribute the failure to the inability to recognize the error in the transfer of information. So it's really about groups and how they share ideas. And again, if we fix the math, right, we still wouldn't fix all of the inability of people to convey their understanding of specialized knowledge to other people. And so these events abound. We can look at the September 11th terrorist attacks, and a lot of the analysis of why this happened was attributed to infighting between the FBI and the CIA. So a lot of people have speculated that, we actually could have avoided the terrorist attacks of 9/11. We had all the information, we just didn't put the puzzle together. This happens in disaster response. So Hurricane Katrina hit. We had a lot of, hurricanes haven't hit in a while, but at the time Katrina hit, we had a very well-established emergency response system. Florida had 3 major storms. There was really no reason for the level of disaster in the response to the disaster that occurred after Hurricane Katrina. So one of the common elements that these stories share is they all involve big teams where people are doing specialized things and they're not working so well. And we know a little bit about why that happens, right? So one of the easiest way to see why that happens is displayed in this graph. So if we think about what happens when you add one teammate to your group, and then we think about the implications of the communication channels. Well, let's say that you're in a team with 3 people. That's relatively simple, although we all have triangles that are hard to manage. That's 3 relationships. Now, what if we go up to 10 people? So we go up to a 10-person team, and now we have suddenly 45 links that have to be managed. And I'm assuming that a relationship between 2 people is the same relationship, but a lot of interesting psychological variables like trust and perceptions of conflict and disagreement are actually not the same relationship when there's 2 people and they have different perceptions. So a 10-person team has 90 of those people thinking about other people kind of relationships. What if we go up to 20? The situation is sort of even more dismal. A 20-person team or group has 190 communication channels that have to be managed. So there's an extraordinary complexity to being a part of a very large group, and there's a lot of places for things to break down. So we shouldn't be completely shocked by something like the Mars Climate Orbiter. So what this says is that if you're working in a team and the team gets bigger, we have to work even harder, right? We have to work not just a little harder, but exponentially harder, because there's a lot of coordination cost to managing all these people, and probably as we get a larger team, people are even more different from one another, so it's harder. So do people work harder when they're in big teams? And actually they don't, they do the opposite. And so there's a large literature on social loafing, which says, well, if you look at a person and they do the task by themselves, this is how much effort that they put in. Oh, it doesn't work on the screen. And then you add another person and you put them in a small group and their effort goes way down, and you keep adding people and the effort goes down and down and down. And so individuals have this tendency to respond to being a group. There's more people to do the work. I'm going to contribute less. But yet we have this other paradox where we're having to add people to the team, but yet it's harder and we need to be putting in more effort and not less. So this presents us with a dilemma, and I'll add one more piece of complexity here. So it's harder to work in bigger teams, but bigger teams are also more likely to have sources of diversity in them. And so this is an interesting analysis that was done looking at teams of people who were funded to do NSF projects. And we know NSF likes to fund projects that involves lots of people and who are working in teams who are interdisciplinary and have PIs that come from different institutions. We think it adds resources and capabilities that should be good for solving problems. So one thing you can see here is that if you add a number of PIs, the number of publications associated with the project goes up. we would expect this. This isn't the per person incremental increase. This is just the total number of projects that project results in. But you'll notice here that as we expand beyond one institution, the benefits of a large team are not as great. So adding more institutions should bring some unique perspectives, universities that are located in different places, different populations, different advisors who can bring new resources and viewpoints to the school. And the other thing is we often think these teams are better if they have more disciplines represented. So problems don't obey our borders. So we can solve big, bad, wicked problems if we bring people who see the world differently together. But the data sort of shows as soon as you go beyond one discipline, the benefits of having a large team don't turn into the same yield in terms of productivity. So all of this to say, why does this happen? And there's a lot of research that looks at the effects of boundaries on coordination in teams, right? And so you could think about the coordination that happens in a large differentiated team, and you could say, well, there's a couple different types, right? So how good is the coordination or the communication or the quality of relationships that happen among people who are the same, people who are on the same team in the same discipline at the same university? And then I could ask, well, how good is the quality of the relations that form among people who are different? So people who have the same superordinate goal, but they're in different fields and disciplines, or they're located at different universities, or they represent different cultural groups. And we've done a lot of studies of this, and these are just kind of means. And we find this trend that within team, right, or within anyone who's the same, the quality of their interactions are higher. And we replicate this, and we replicate this again, and we replicate this again. And we see this same pattern that regardless of what the difference is that separates the teams, that as soon as you create small teams, there's a tension in them working together. And so nature doesn't let us design the problems, right? So we're given the problems, we're given the challenges, and we have to put the people together that can solve them. And we know that solving big, challenging problems requires people to come together who have different ideas, different background, and different experiences. So we want to produce the art, right, that comes from these differences melding. But at the same time, there's kind of a peril of too much blending, right? So if we try to build these very large team where people have lots of relationships across teams, we can wash out the beauty of the team, right? So we know from the social loafing literature that people need to feel like they're in a small team. As soon as their experience in the team is that I'm in this big, large group, I'm not motivated to contribute to it anymore. The other problem with being in a very large team is that there's a reason why people are specialized. There's something really good for thinking about teams that happens in my lab when I can talk to my graduate students and postdocs, and we can think about teams, and we've read all the same papers, right? We can work on something and work with a data set in a way that we can't if we're talking to people who don't speak our language. But that doesn't mean we can't benefit from getting on Skype and having a meeting with the Sonic Lab at Northwestern, who's going to see the problem in different ways and have new kinds of analytics that we haven't thought about, right? So there's sort of this tension that we have to manage when we build these really big teams, that we want to preserve the essence of the team, right? It's what gets people motivated, excited, and able to apply what they're doing and they're good at. But we need teams to be bridged together. And so the first puzzle that we have to solve is how do we build really good, big teams? And so I'm going to use this word, multi-team system, to describe this collective of a big team where people are working towards a superordinate goal, but they're doing so by also pursuing a goal within a team. And so we published an academic ebook that nobody reads called Multi-Team Systems. If you're interested in the topic, I can recommend to you that you pick up General Stanley McChrystal's book, Team of Teams, which is much more engaging, but it's talking about exactly the same phenomenon. One is a bunch of researchers talking about it from an organizational science perspective, and another is a general talking about it, with definitely much better visuals. So we're studying multi-team systems, and we know that in multi-team systems, people have to manage ties. They have to manage ties inside their teams with people who they're the same, and they have to manage ties with people outside their teams. They need outside ties to bridge teams, and they need the individual teams to feel like small teams, right? So that's our riddle that we have to solve. And so I'm going to give a notation system that I'm going to use throughout anytime we present data in this talk. And so it's good to kind of show the notation. So people are now being reduced, all of their complexity, to circles. Sorry. And relationships between people are being reduced to lines. So whenever you see two circles and a line, that is referring to something like the quality of their communication, or it could, if there was an arrow there, it could be how much one person influences another person. People who are the same color means they're on the same team. They share a local goal, right? So this could be people who work in a certain lab, or people who work in a given department, or people who work in a given functional area, like marketing versus sales versus product design. And then another color means we've got a different team, and all of this notation together is what we mean by a multi-team system. And so we're interested in understanding these and their power for enabling people to work in very large teams without the costs that come from the coordination demands or social loafing. And so now we're going to study the patterns that evolve in these multi-team systems as they start to develop relationships. And so we could think about the patterns of ties that they form between teams. And so every one of these individual teams that works in a multi-team system has to evolve some approach towards its external environment. So how much am I going to form close working relationships with people in other teams? And MTSs vary on this quality. So in the top left, we see a case of a very isolated teams, right? So this is the classic grant proposal that no one in this room has been a part of, where PIs come together, they write a grant, and then they take the money and they go do separate research, and they come together once a year to write a report, right? Where they block, copy, and paste what each person's done. Again, doesn't happen here. The middle diagram is the case of connected teams, right? So you can definitely see lots of relationships that are tightly clustered within the teams, but there's some bridging ties. So there's conduits for information exchange. To go back to the grant example, somebody from this lab attends the lab meeting of someone from this lab, right? So they can kind of beg, borrow, and steal ideas, and there's a mechanism for them to transfer across. And then here, we might as well not even color code these nodes, right? Because if we were to do any kind of a community detection, we would see that there really aren't different communities in here, because this is really just one essentially huge team. And so we want to know how much do teams, when working in multi-team systems, connect to the outside. And so we'll plot this by the percentage of possible outside ties that the team maintains. And maybe we think it's going to be a normal distribution. Anyone? Kelsey, thank you. Maybe we don't. And it looks like this. So the vast majority of teams working in multi-team systems activate fewer than 20% of their outside ties, and they have very few ties with other teams. And you might say, well, maybe that's good, right? So it's certainly not bad for a harnessing their effort inside the team perspective, but not good for ideation across people who have different ideas, which is what we're trying to harness with large teams. And so then we could ask, well, how many inside and outside ties should a team strive for? What should be the goal? And the first way we can answer this question is by looking at the relationship between the density of their outside ties and their ability to be committed and to identify with the superordinate goal, right? We know this is going to predict the extent to which that team is willing to work hard and stay the course and make sacrifices for the good of the long-term goal. And we see, something interesting, right? This is where I told you everybody lives. So this is the zone of reality. What teams naturally do when left to their own devices. Most of them do this, and it's sort of random, right? So some of them identify strongly with the superordinate goal, and some of them don't. But look what happens when they start to do more external boundary spanning, right? So in terms of identifying with the superordinate goal, we start activating more external ties with other teams, and we see an immediate increase in superordinate goal commitment. But before we get too excited, we have a second relationship that we have to look at. So how does this same variable on the x-axis relate to those same people's identification and commitment to what they're doing as a team, right? This is the overblending phenomenon that I was talking about of there's a reason why people work and live in teams and why they do specialized things. And so what we find here, and the actual fitted line is actually a little more curved than this, is that after a certain point, so initially adding external ties actually only helps your team. You know you're great when you start having a few ties to the outside and you see how different other teams are from you. It sort of builds your attachment. But after it gets to a tipping point, it starts to go down, right? And so now you have too many external ties, your boundaries spanning too much, and you no longer identify with that small type group that you're a part of. And so we want to bridge the boundary, but we don't want to sink the team, right? And so we fit both of these predicted values onto a heat map so we could quickly see what the kind of optimal level of boundary spanning would be for teams. And we see that it's right about here. So if we put the little slider bars on, the density of inside ties should be high, right? So people within a team need to have tight, trusting relationships with each other, where everybody has a relationship with everybody else. But if we look between teams, it needs to be moderate, right? After this point, we start to lose people's commitment to the home team, right? So we need about half of their boundary spanning ties to be active. So this brings us to the first signature of a dream team, which is that first we need to think about moving from big teams, where the goal is massive integration across everybody, to thinking about how we can structure people into communities of teams where they live in a close-knit neighborhood called a team, right? So we think from teams to multi-team systems, and we have this sort of signature that successful teams are following this 150 rule, where they're activating as many possible ties within their team, but only 50% of the ties outside their team. And so the second puzzle that we have is leadership, right? So I've talked about this in the aggregate. People are working together. They need to have the right kind of boundary spanning ties, but there's plenty of examples of groups that have the right structure, but they don't have anywhere to go, or they don't have the right direction, or something changes in the business model or the ecosystem that they live in, they don't recognize the information and they become extinct because of it. So that's the question of leadership, and I'm going to bring back some stories. So if we revisit the case of Hurricane Katrina, I said this was an interesting organizational failure, especially for the reason that Florida and the emergency management system in the Gulf states had such practice, right? Frankly, everything was activated. They have a very clear hurricane response plan. Who's in charge, when, how does power transfer as the storm changes, approaches land, makes landfall, and leaves. And yet, the case has been analyzed repeatedly, and it comes down to this failure of initiative. The resources were in the right place. Nobody knew what to do to integrate and work together. We can contrast that with another great story in US history, President Kennedy's famous speech where he said, "We choose to go to the moon." And he spoke before a conference, and this was his response to the Russian launch of Sputnik. And he said, we're going to respond not by fearing the Russians and thinking this is a terrible day for America, but we're going to go way bolder than launching a satellite into space. We're going to put a human being on the moon. And of course, we have that famous day where Neil Armstrong touched down on the moon, and it was a huge feat of mankind. And of course, there were lots and lots of teams, even some failures, in between before we reached that great day. But one thing I want to call your attention to in this case study, of course we think about Kennedy, just like we do with the great inventions. But there were also lots and lots of leaders in engineering teams, leaders in design teams, leaders in manufacturing. So this wasn't a single unitary leader that enabled us to accomplish this. It was a system of leaders who alternated taking direction, providing vision, providing support, and working with each other to make sure that this large system of teams was able to get to the ultimate prize of a moon landing. And so we know that large systems rely on leadership and not a unitary leader. And we ask ourselves, what are the principles by which leadership comes about in these systems? So we want to know, in Katrina, why did it not happen? And in the moon landing, why did it happen? What was different about those systems that made one work and one not? And so we're going to do more of these humans as graph scenarios. And these are samples of students that we watch. Students are wonderful because, well, they're students and they have to do our projects. But the other reason that they're scientifically wonderful is that they're comparable, right? So we have a setting where we can say we're going to start a bunch of zero history groups, and we're going to give them exactly the same task, exactly the same resources, and they're going to work together. And this was a social entrepreneurship project where we teamed up business students in social entrepreneurship at a French business school with ecology students who were at George Mason taking an environmental ecology course, with Georgia Tech social psychology students who are learning how to change human behavior and attitudes. And so we teamed them up and said, come up with an app that if humans use it, it would change their behavior in a way that would promote environmental sustainability, right? So they couldn't do this without all three teams having input working together. They could have a killer app marketing plan, but if they didn't get input from the ecology teams about what humans are doing that are causing the behavior, and they just said, well, we're just going to do recycling, right? They wouldn't have a big net increase from it. And if they didn't work with the psychology team, they would have some interesting app design, but it might not be linked fundamentally to the attitudes that are most proximally giving rise to the problematic behaviors. So this gave us kind of an ideal task where we could study from teams that start with kind of no leadership structure to how it comes about. And so the only kind of notational differences here is that the size of the nodes has been introduced, and size is how many followers you have. So if you're a bigger circle, it means people are relying on you for leadership, and if you're a small circle, not many people are relying on you, and if there's no ties, it means you're a rogue team member who's not following anybody. The other interesting notational difference is that I've color-coded where the tie is located. So with leadership, we can think about the different levels that this happens. So there's leadership between people in the same team, right? Which is getting people in the same team to work towards the goal of ecology. But then there's leadership that permeates the boundaries between teams. It's when somebody in ecology is influencing somebody in psychology. And so we've color-coded those so we can see. And now we do a fancy network analysis and we say, okay, what are the self-organizing patterns that explain how this graph came about? What are the rules that allow us to reproduce the observed structure that we see 4 weeks after these people work together? So they start, they have nobody's following anybody, and a month later we end up with structures like this. There's two structural signatures that explained how leadership came about in almost all of these multi-team systems. And this is the first one. And one thing that you'll probably notice is that there's big circles and there's little circles. And the big circles, we call them hubs, but these are people who have a lot of followers. So this is a multi-team system where people are all following a rule. So if we want to predict when a tie forms versus when a leadership tie doesn't form, we can trace it back to people following this simple rule, which is called a lot of things like popularity and hubs and preferential attachment. But essentially the rule is follow the person other people are following. So as soon as you have one follower, you're disproportionately more likely, all things equal, for somebody else to start following you. And so this is a general tendency of how leadership forms, that it forms in hubs. People seek a hierarchy, and they tend to concentrate leadership in the hands of a few people. Now, the second signature that we see is here, is that you'll notice there's more red arrows than black arrows. And I should mention that it's not, the pure count is a little bit misleading because there's many more possible arrows between leadership ties of people in other teams than there are within a given team. So the second rule that people follow is team preference. I'm going to follow somebody who's in my team, and I'm not going to see people who are in other teams as leaders. I'm not going to rely on them for influence. But influence across teams, across fields and disciplines, across institutions is exactly the kinds of influence that produces the great ideation, or the ability to know lots and lots of things that you don't really know, but you want to integrate into the problem. And so, okay, this is interesting. We know groups follow these two rules. They form hubs. They show preference for people on their own team. But now we say, well, what should they be doing? Because some people could say, well, hierarchies are good, right? They're simple. Everyone has some clarity on what to do. And so now we take and we classify this. So while most teams form hubs, or most teams follow an in-group preference rule, there is some natural variation. So Some of the multi-team systems were kind of low on this inter-team leadership, and some were high on this inter-team leadership. So now we're flipping it, and we're saying how many leadership influence ties are permeating group boundaries, and they're comprised of a person in one team who's following or taking direction from a person in another team. And we plot that against the innovation. So we had subject matter experts rate the innovativeness, the novelty, and the utility of the smartphone apps that these students came up with. And we plotted it against this inter-team leadership, and we see this positive linear relationship. So remember this truth in advertising? I wasn't lying. There's generally not a lot of inter-team leadership that happens, but even in the restricted range, we see this positive effect that as the multi-team systems start adding bridging ties where people in one group influence people in another group, we see this gain in innovation. And the R-square is 34%, and we controlled for how much leadership. So we controlled for just how many people are following other people, and we still see this gain in terms of how many of those ties are between groups. So now we look at this hub idea, and we say, well, hubs are really the ultimate concentration of leadership, right? So imagine you have one hub, and it's kind of a star pattern, and everybody's relying on the same person for leadership. The opposite of that is what we call shared leadership, and that's where different people are leading. That's back to Kennedy and getting us to the moon. So Kennedy gives the speech, and as soon as Kennedy gives the speech, the director of NASA takes action, and NASA goes and starts funding different research projects, and those PIs take ownership. And then postdocs and graduate students within their respective laboratories start taking leadership when the problem demands their expertise. And you have this dynamic system where over time, leadership is not concentrated in the hands of one people. Leadership is rotating, and there are lots of influence conduits. One person in one team realizes the solution they're working on isn't going to work. They have the ability to move the whole system because they can speak up. If it's all in the hands of the hub, that's great if your leader knows everything, but I think we've already established that none of us in 2015 know everything. So now we computed a metric of shared leadership versus concentrated leadership. And so given some natural variability, to what extent do those track to innovation? And here we've controlled for the amount of leadership, and we've controlled for inter-team leadership. And we can explain another 9% of how innovative their final apps were by how much they shared leadership in these multi-team systems. So even participation, right, again, controlling for amounts of leadership ties is an important factor in how innovative these systems are able to be. And so this brings us to the second signature of the dream team, which is that they need a leadership architecture that has these two properties. One, the leadership has to have influence conduits that allow teams to influence each other, people who see the world differently. The second is they have to share it. There has to be an even responsibility that people take for leading the group. That doesn't mean every day, every act, but that means over the course of working together, they're willing to take direction. So people are willing to step up and they're willing to step down. And so our second decoded secret is we need to move from thinking about leaders as these unitary people to thinking about leadership, which is a property that's manifest of a group. And so one of the takeaways here is that we find 43% of the final innovation of groups can be attributable to how they're designing their leadership structures. And so now we get to the third question that we need to tackle with dream teams, which is, where do they come from? So how do they come together? And I'm going to tell one more story, I promise, between two gentlemen named George Box and David Cox. And George Box and David Cox were both serving on the research committee of the Royal Statistical Society. And they had a common friend who said, you know, George and David, you have these interesting names. Have you ever thought about writing a paper together? And they said, well, that's kind of a cool idea. We should think about writing a paper together, but what would the paper be on? And David says to George, or George says to David, you know that interesting play where Box is renting the apartment in the day and Cox is renting the apartment at night, and they have the same landlady who's collecting two rents and neither of them know it? And they said, yes, that's it. we're going to write a paper about data transformations. And so we have the Box-Cox transformation, which I'm told is the 9th most highly cited paper of all time in statistics, which is enormously useful. And it's kind of fun to think about how this team came together, right? So the story illustrates some of the reasons why we know that people end up collaborating. The first one is propinquity, right? You have to have a way to meet. So people who work at the same university are likely to work together. People who attend the same conference and are in the same discipline, simply because they run into each other. The second thing, social relationships. They had a mutual friend who suggested the idea. Lots of times we team up with people who others recommend. Oh, you're interested in this? Well, I know this person you really should meet. Or you're looking to hire somebody who does this? Well, I have just the person for you. And the third thing is ideas. So sometimes people are attracted to a problem, and that's what draws them to want to work together. And so this is kind of how teams have traditionally come together, but we can ask the question, can we make it better? So can we matchmake dream teams? Wouldn't that be nice? So essentially, people have been matchmaking for many years in personal lives across cultures, and I hear that there's some success with that in some countries. And in the US, we have these very popular online dating sites, eHarmony, Match.com, that claim a lot of success in terms of the subsequent reduced divorce rates of people that find each other online. And the theory is something like, well, you can consider factors that are deep characteristics of individuals if you meet in that way that you might not otherwise consider, right? You normally meet people and you have access to kind of very surface level information. So we said, well, can we build the same thing for teamwork? So this is the My Dream Team Builder, and I'll acknowledge Nashir Contractor, who is here. And we had this idea for building this recommender system to help people find dream teams of people to collaborate with. And so the first thing that this tool has is an ability for some administrator functionality. So we use this right now in our classrooms. So we want to form interdisciplinary teams, and we want 2 people from Georgia Tech and 2 people from George Mason. But whatever the parameters are, we kind of use this to structure the little world that a particular instance of finding team matches is going to happen in. The next thing that happens is people who are going to want to find a dream team log in, and they fill out background measures. So it links to psychological surveys, and we assess a whole variety of traits, which I'll talk about in a second. And it gives them a network roster, and we ask them about their social network. So who do you know? Who have you worked with before? Who have you liked working with before? Who would you consider a friend? And then the user goes in, they get a quick tutorial. This is how your Amazon recommender system will work. They circle factors. How important are these things to you? What's your composition rule? Do you just want one person that has this? Do you want some people to have this? Or do you want everyone on the team to have this quality? And so they set up queries, right? And they say, all right, this is what my dream team would look like. And they can go through and pick professional skills, right? So this is like data collection, data interpretation, things that you might not be good at, that you might want somebody who has those skills. You might care about leadership experience. I'm a staunch introvert. I need somebody who's going to take direction and tell us what to do. Or you think, well, I'm a leader and I don't want to have too many Indians here. You can select on social skills. You can select on creativity. So a lot of some of the teams we use this on are doing real design-intensive projects. What about your teamwork values? Are you a lone wolf? Do you want to divide everything up and work separately, or do you want to meaningfully collaborate? What about intercultural sensitivity? So people with similar attitudes. Homophily, heterophily. So you can't find out, unlike dating websites, you don't get any information about this is this person's level of extroversion or this is their leadership score, but you can put in homophily and heterophily so that you can find people who are similar to you on certain characteristics. You can also be a pragmatist and say, well, I want people who are available to meet and work at the same hours that I am, so you actually can work together. And you can put in social network factors, like I want somebody who's connected to some common people, so a friend of a friend. Or I want people who are brokers, who sit in interesting positions between different groups who don't talk to each other. Or I want really popular people, or I don't want popular people who are going to have no bandwidth to work on things. And then you get a list of teammate recommendations along with a match score, right? So based on the query that you put in, these are some people that you might like to work with, and of course we can look at their profiles and read a little bit more about them. And if we like them, we can send them an invitation and say, hey, would you like to join my dream team? And when we have downtime and we're waiting, we can review invitations that other people have sent us and see how much they match with existing queries that we've already set up. And we can reply to their inbound invitations if we want to form a team with them. If we're not getting any invites, we can go revise our profile. Maybe we were a little too harsh in what we said we wanted, and we should kind of lower the bar so we're not scaring away potential team members. And the other thing we can do is break up. So, maybe we found a better offer and we were partnered with these 3 people, but now I got invited to be on this team, which looks like a better match for me. So they can cut off their team relationships, and the administrator or scientist who's interested in team assembly can monitor the process live. So you can see what the chains are in who's connecting to who, how many teams have formed, how many people haven't formed. And so what if we gave this to 95 students in a class and said, you have the option, you don't have to do this, you can form any way you choose. We're happy to assign you to teams. You're welcome to choose your friends or people you already know, or you can use this tool to form into a team. And we do this for a couple reasons. One is pragmatic, right? It's kind of a fun technology for allowing people to actually assemble into teams with people that they don't already know. The other reason we do it is very important, which is we want to study the attraction process that happens when people find collaborators. So if we think that it's critically important that we can build effective, large, differentiated teams with lots of expertise to solve problems, well, we need some way for these people who don't live in each other's worlds naturally to be able to find people who are compatible on a variety of characteristics. So we ask, what are the factors that these people will use in choosing their teams? And we kind of had 2 theories that we're looking at. One is, you'll use a technology like this, and people already have these biases about who they want to work with, and it's only going to make it easy for you to make systematic your biases, right? You just program them in, and you'll never work with anybody who's different from you. So that's a possibility. And we know people have biases along these lines. They like people of the same gender, same race, ethnicity, age. But another theory is, a lot of times in teams, people are very pragmatic, and they want to work with people who are instrumental and who they're actually going to do something great. If they're going to put their time into it, they want to have people that it will really pay off to work with. And so the problem is we know there's these underlying deep level differences in people, but you don't get to know what they are until it's too late, right? So people that you're really not going to work well with. But wouldn't you like to know that before you submit the grant proposal or before you take the overseas assignment together and you find out the hard way? And so the other more optimistic view is that having a technology will allow people to transcend some of their natural people that I have access to. And so deep level characteristics are things like expertise, skills, leadership, interest and ability, personality, or attitudes. And so this is what people actually did. There were 6 teams worth of people who said, I don't want any part. Instructor assigned me to a team. There were 14 teams that formed entirely through the tool. And there were 10, we're going to call them blended teams. And the blended teams were a mix. Some of them were teams that formed organically, like, hey, you're in my fraternity, would you like to be on a team with me? Some were partially formed, like 3 people who came together in the tool, and then the instructor put some other people on that team. So they're really a mix of teams with some agency and some not. And this is the graph that we can again use to look at and understand the teammate attraction process. Dots are people. Green lines means you formed a team, right? So you decided to work together. Black lines mean you had an existing network tie with that person and you enjoyed working with them. And now we can run our same self-organizing analysis that we've done in the other studies, and we can say, tell me the rules that produce this graph. What are people doing in evaluating other people that explains the structure of who ends up in a team with who? And so the first thing that we look at is the tool use and prior collaboration. And so again, we've broken out, these are odds ratio. So you're predicting, you're controlling for every possible tie. Well, if we take two people, how likely is it if they have this thing in common or if they don't have this quality that they would end up in a team together? And so we can see one thing that happens is you're 167 times more likely to end up in a team with somebody that you have a prior collaboration with if you use the tool. If you were assigned by the instructor, of course, there's no preference based on prior collaboration because you're not making a decision. So that's sort of a validation. So people rely on past behavior. The next question is, what about surface things like gender? So do people want to team up with people who are similar, of similar gender? We know that happens without using a technology. And so here we've color-coded the nose based on color, but we do a little more sophisticated analysis of that. And we see that actually the blended teams, which are the ones that form more organically, are actually the ones that have the gender homophily preference, but the ones who use the tool had no gender homophily preference. So it does away with a gender preference. We also asked about attitude homophily. And so this was an intercultural project. There's a team in France, a team in Washington, and a team in Atlanta. And so we gave them a scale of attitudes towards intercultural interactions and skill at working with people in other cultures. And we looked at, well, does homophily in those attitudes predict who ends up working together? And we found that people who were using the tool had a greater difference in their attitudes. So it enabled them to find people who were similar to them on something that would be invisible otherwise. And so we sort of start to find that people have these new rules of attraction that, in contrast to Box and Cox, they include some of the factors like prior collaborators, but they also look for other deep level characteristics like similar attitudes, and we see less reliance on things like gender. So now we ask, well, okay, great, people use different rules in finding their mates in teams, but are the teams happier if they formed using a technology where people chose one another based on their worldview of what they wanted? And the first thing we looked at was the communication density. So this is about 2 or 3 weeks after the team assembly process when and these people are working together. And we see, recall, this is the My Dream Team Builder. These are the blended and these are the instructor assigned. They're talking to each other a lot more. They're also more evenly participating, right? So we see a big difference in, it's not just one person sending emails to everybody else saying, please do this, why is no one responding to my emails? But everybody is an equal participant in the team. And the third thing we see is they're more confident in their teammates. So we asked everybody to tell us how confident they were in everybody else. And we found much greater confidence levels between the tool and those, for example, that were just assigned to teams. And so this brings us to our third signature, which is really needing to think more about being able to enable teams who self-organize, as opposed to teams that are formally staffed and appointed to work together. And this is supported by this finding that teams who are matched online are twice as confident in each other's ability than the teams who were appointed. And so we've sort of figured out these three interesting puzzles about how to work together in teams. And now I want to give you some insight into what we're decoding now. And so NASA released this interesting report this year about our journey to Mars. And they said, we're on this journey and we're not just going to visit, but we want to stay there. We want to figure out how to be Earth independent. So by the end of 2020, we would have teams of people living on Mars and figuring out how to produce food and get access to water. Hopefully we've started that process. And a couple interesting things in this report. One is the massive level of interdisciplinary and international collaboration that it's going to take over a sustained period of time to be able to do that. So I'm seeing multi-team systems everywhere. The other fascinating thing is that communication's off the table. So these teams are going to have to work together where they're used to being completely reliant for all problem solving on what happens on Earth. We have lots of smart people that can troubleshoot a problem in an EVA suit. we won't have that. And so on a Mars mission, it's a 20-minute communication delay to get a message or a packet of data there, and it's 20 minutes to get it back. So the nature of teamwork is going to have to change dramatically. And so we have 3 new projects here at Georgia Tech that we're working on to try to enable this multi-team, big team collaboration. One is on rapid teaming, a crew recommender project, and maintaining shared mental models. And so the first one is the interesting problem of who do you send? And so traditionally, astronauts have been one of 2 kinds of people. They're either scientist engineers, so they know how to fix stuff and they know how to do good experiments in space, or they're pilots / ex-military. So they know how to fly ships and dock things well. But when we think about a Mars mission, we're only going to send 6 people. They have to have medical, some redundancy, so perhaps 2 surgeons. They definitely have to have an engineer and a scientist and somebody who can troubleshoot a lot of the life support problems that they'll be experiencing. And so there's a massive amount of information that has to be concentrated in just a few people's heads, in addition to their ability to live together in a room a tenth of the size of this room for 3 years. The second project is designing their job. So figuring out how we can get these people to be able to be isolated and confined and alone for long periods of time, and then suddenly a life or death situation happens, and you have to work seamlessly with 2 Russians who barely speak English. And your life depends on it. The third project is how can we, we're not going to give them surveys of how is this going, and then wait for the data to come back, and then design an intervention, and then send it up to them and see how it goes. So we need real-time detection systems to have ways of analyzing the communication, speech prosody, people's eye contact, gaze, and be able to tell, is this team functioning, is it on course or is it not, in very consolidated ways. And so that's our third project. And so, just to give you a scope of the challenge, here's the International Space Station, which is in lower Earth orbit. It's about 250 kilometers from mission control in Houston at any one given time. And it just sort of goes around in low Earth orbit. And we did a whole bunch of interviews with astronauts last year, and there are plenty of intergroup challenges happening there. But now when we talk about a Mars mission, it's not close. So it's 54.6 million kilometers away. If you saw The Martian, you sort of get a window into how far that really is if you needed to send food. And to further complexify this, there will be multiple command centers, so it won't just be US mission control. There will be different space agencies that have real authority for the mission, and of course their political relationships are going to be changing over a 3-year period of time. There's going to be lots of engineering, mission planning, vehicle design teams that are in play supporting these different mission control centers, scientific teams whose lifeline of research is here. And we're going to send a team to Mars that's going to be able to work with all of these teams. And so, right now we practically have the ability to read each other's minds compared to the level of coordination that they'll have, which is more like Christopher Columbus leading the Nina Pinta and the Santa Maria. And so with that, we have lots of challenges to solve, and hopefully these kind of 3 decoded secrets stick. So making big teams work by making them feel small, enabling teams to lead themselves, and enabling better ways for teams to come together. And with that, I want to thank our research sponsors who've made all of this exciting work possible, and especially my research team at the Delta Lab across the hall, who made all of the analysis and fabulous visuals that you see today possible. And my son is now carrying on the tradition. He's a rower. But I haven't shared a lot of these stories with him just yet. I don't want to scare him away. So thank you so much.
Questions, and then there's a reception outside where anybody can, of course, ask Leslie questions individually.
Yes.
I have a question. I don't know if the issues are more around how teams are selected, but one of the issues in corporate America we have now is that we typically have people who serve on teams that are spread all over the globe, and we find proximity to each other and to be a real challenge. So have you done any kind of look at, sometimes it's even 2 floors away from each other that you have difficulty communicating, but especially global teams?
Yeah, I think it's 1 floor. So David Crackhart did this, he's at Carnegie Mellon, and he did this interesting study repeating some of the old dorm studies that were done in the 60s, looking at the propinquity effects of who college freshmen make friends with. And he repeated it in a Bankers in Manhattan and found it was just 1 floor, right, was enough to separate people. And the problem with global separation is that there's also these other differences. The cultural differences, the real time zone difference where they're sleeping when you're awake, and then the other difference of being in different organizations or being in different branches of an organization that have different kind of local organizational cultures. One of the cool things we did last year was worked with an industrial engineering PhD student at Northwestern who built an agent-based model of this. So we took social science data to program it, and we found that those differences absolutely compound, and that there's a distinguishable effect of the cultural organizational differences and also an effect of the distance. And if you add them together, it's of course worse.
Have you tried this tool, this online tool, to connect people who are not
well, we haven't done it in corporations, but one of the inspirations for creating the tool was very practical of forming these big teams that we have in classes where students in France and students here are working together in teams. And so they complain about the people they get matched with. So we thought, there's something to the agency of, when I work on a research project or I work with doctoral students, I choose them and they choose me. And there's something to that agency of, we're going to make it through this conflict because we picked each other, right? And I picked you because you can do something I can't do. So now when you disagree with me, I'm going to see that disagreement differently than if I was just told I had to work with you. So that's kind of one of the new directions. Yes?
The individual level of the connectors, of who are those help? And can you predict what makes a connecting hub?
So in general, we actually just finished this meta-analysis where we looked at all the data that's published that's looked at personality traits. So things like extroversion and conscientiousness and agreeableness. And actually, if I had to say the single best trait predictor, so we looked at 3 properties of networks. So people who end up being brokers, people who have big networks, people who have diverse networks, and people who have big, diverse, brokered, and one other, which I'm forgetting, breadth. And self-esteem was the biggest sort of predictor across most traits. So people who have high self-esteem end up in more central positions and positions that connect different people.
I was interested in a variable that you brought up that didn't talk much about, which was the idea of a shared mental model. I've heard had some other talks where people have said it doesn't mean everybody sees things the same way, which fits with what you're saying. But I wondered if you had either thought more about it or learned more about it. I'd be interested in that.
So there's kind of 2 camps on that, right? And one is more of an everyone sees things the same way camp, and there's a lot of research that's come out of cognitive psychology that looks at the actual similarity in how people understand a problem. But the other part is more in the transactive memory space, which is we actually don't need to see the problem the same way at all, but we need to see our relationships with each other the same way. And we need to have a directory of where expertise resides, and that part needs to be similar. But we're kind of taking, in our project with the astronauts, we're trying to look at a blend of both. So we're looking at the transactive memory model, but we're also saying, there's some elements of having a similar strategic understanding of the mission, which, if you watch The Martian, did people see The Martian movie or read the book? No one has time for that. It was a fantastic book and a pretty good movie. But, there's a lot of scenes where you see the Ares crew that's left Mark Watney on Mars, and then there's the crew on Earth, and there's times where they're all making different decisions because they have a different strategic understanding of what's important. And so that's an element where what's broken is not knowing who's got what expertise. What's broken is the criteria that you're using to judge a win on that mission. And the three see it very differently. Yes?
Do you factor in the complexity of the overall goal in terms of how much interaction should be between teams and things of that nature?
Certainly. So we are really interested in highly interdependent, right? So one way to boil down complexity is how much mutual reliance there is. So person A, do they need person B to do what they're doing? You know, are the thoughts, feelings, and actions of one person contingent on someone else? And so a critical kind of assumption of research is that that there is an interdependence there. So yeah, that's obviously really important, or you would not want, you know, it would be counterproductive to have lots of boundary spanning going on. It would just distract people from doing work that they could do by themselves, essentially. Yes?
Well, we have an organization that spent an awful lot of time assembling teams called the Army.
Yeah.
Over great distances with disparate value systems and the different levels of experience. And of course, one of the things we do is we spend a certain amount of time telling you you're going to have the same shared vision.
Mm-hmm.
How do you adapt that or make use of that for a bunch of academics who all think they're the best things in sliced bread?
Yes. So the interesting thing about the Army is that their selection model ignores teamwork. And this is something that they're actively funding a lot of research to try to change. And they're engaged in some interesting collaborations with people like ETS, the people who make the GRE and the SAT, to try to isolate how can we identify in an individual their propensity to be a collaborator. And the Army's very interested in that. But their current selection models don't have those predictors in it. So it's very much you and your job performance, and not, and you know, how can we match you to jobs that you'll be good at. But now they're recognizing that when the job has interdependence and collaboration built into it, that we don't have a good sense of what the skills are.
Yeah, but we have always formed teams.
We have.
And terribly interreliant teams. Like if you don't do your job, I die.
Yes. Yes. We've always formed teams, but there's a lot of issues with like the troop rotations now, where there's a lot of change in the teams. So it's not, oh, I'm with the same people, but this person has a leave and they go and I get this person assigned and I'm deployed for longer because they don't have anyone to replace me, and now I'm being repositioned to this unit. And so it's also, you know, the sense of, oh, I have relationships with all these people is a little more in flux because of that. So, but I mean,
That's not a new phenomenon. I mean, I spent 24 years in the military, so I'm used to that. And somehow we muddle through for all these years. Can't you use some of our experience in other situations?
So take military experience of forming teams into academics.
Well, or any situation, but I mean, there's hardly any two more disparate cultures than the military.
That I would not completely disagree with that. But the challenge there is that the military selection model, I mean, is that what you're asking?
No, I'm just
Okay.
I mean, make use of all the experience we have, because I mean, this is not a new phenomenon. I mean, ever since militaries reformed, you had guys that different skill sets, different attitudes, different education, whatever, and then you're going to put them together in a foxhole. And then the reliance is obvious.
So the military actually has funded a ton of the research, and still does, on teams and networks and large teams. The one thing I will say about that is that they won't let academics study their teams. And so even DoD projects that have been directly funded by the military, and they've said, we really want you to use this data, and they can't get clearance for it.
I mean, going back to 1975, there's a guy named Justin Cononos, and I think he was from DePaul, that went and studied all the naval basic training classes that went through, and did quite a lot of analysis about how teams were formed, how relationships were formed, the effectiveness of the different classes, etc. So
Yeah, no, I hear there are, and there's people who have security clearance and people who are PhDs and are active officers in the military who do a lot of that. But I was on an NRC study last year, and one of our main recommendations, talking to people, funding agencies at DoD, talking to enlisted folks, was that there isn't enough. And they were saying they're funding all of this basic research on collaboration and teamwork, but providing no access to military personnel, and it's in the BAAs that they release. So I say that, as a researcher, I've kind of tried those channels, and it's sort of frustrating for the military that we work with, as well as frustrating for us.
Let's take one more question.
Yeah.
And then we have a reception.
Okay.
Is that me? Good. I manage software teams a lot in my career, and they're an unusual group of people to manage first. But one of the things that we found quickly was when teams got beyond a certain size, they collapsed to the communication requirements. And very small teams were often much more effective. One of the things you didn't speak to was the quality of the people in those teams. Because if you take 4 stars or 5 stars in a team, they can accomplish amazing things if they have a very clear mission and they have a lot of buy-in to that mission. They really feel ownership for their project. But you could take 4 or 5 other people that are average, and average people can't accomplish a third as much as really spectacular people.
Yeah.
Huge difference there.
There is a huge
If they feel like
difference.
they're carrying somebody, then it can really hurt the cohesiveness of the team.
So these data are deliberately don't have those star qualities, right? But a lot of the studies that are published on these same issues look at things like academic teams forming. And one of the big predictors is, so people all want to work with the very small subset of academics, for example, who are publishing loads and loads of paper. And it kind of raises this debate, right, about to what extent should that, that's a self-repeating cycle. And to what extent do you want to let average people have the chance to develop versus, keep feeding this tiny little group of people? But again, it depends on what you're evaluating. Do I want to win on this project, or do I want to win in developing a pool of people, right? So that I can develop stars of tomorrow who haven't come up yet.
Yeah, I think the teams, if they've got someone that's less experienced but very bright and very passionate about it, they're fine with carrying that person. If they've got someone who is really not a very hard worker and not passionate about it, it's much different. The other thing I noticed, it was a count of papers. It wasn't a count of referenced papers, and some way to measure quality of those papers. It may be easier to churn out a lot of papers, even if they're refereed papers. But the quality of the papers is something that there are some ways to measure.
And that's in the UTI study that's published in Science, they have quality measures.
Yeah.
The one that I showed that you're talking about, Jonathan Cummings and Sarah Kiesler's, they don't have a measure of that. It's hard to get, when you analyze these big data sets, it's hard to get that kind of qualitative information about it, but I agree it's important. And it's an interesting question. So
Let's repair to the refreshments, and thank you, Elizabeth.
thank you.
Not on. Hello, hello.